These questions begin by saying you are given the task of testing the following claim or hypothesis by first completing the topic and research question. So we have to complete the topic and the research question. So the hypothesis is talking about the mean time students spend in the library is no more than 5 hours. So this, an appropriate topic for this hypothesis would be students in the library. And the research question, an appropriate research question could be, for example, what is the average time that students spend in the library? Okay, and the hypothesis, a possible answer to the research question, the mean time students spend in the library is no more than 5 hours. So this hypothesis has to be tested, and here the information is given to test this hypothesis. So to test this hypothesis, we must use z-test for mean, because the hypothesis is talking about the mean time. Agreed? So we have to use the z-test for mean, and to begin a z-test for mean, we have to translate the stated hypothesis to symbolic form or mathematical form. Okay, so the worded hypothesis is saying the mean time students spend in the library is no more than 5 hours. Okay, so we need the symbol for mean, we need the symbol for no more than 5, or no more than. Now the symbol for mean here is the population mean. So we're talking about mu. Okay, so the mean, the population mean, is no more than. The symbol for no more than, we can resort to the table to look for the symbol for no more than. Where is no more than? Look, no more than is right there. So no more than is an HO symbol, all right, because it comes under the heading of HO, and the symbol for it is the less than or equal to. So the HO, here it is, the mean is no more than whatever value you are talking about. In that case, I think it's 5. So this is the worded hypothesis translated to symbolic form. Here's a symbol for no more than, the less than or equal sign. So the mean is no more than, let us look for the no more than symbol, less than or equal to, no more than 5. So here we have translated, and we have to identify, as the step C, identify what type of hypothesis, if it's a null or an alternative. So since this symbol carries the equal sign, it is a null hypothesis. Okay, and it will form the claim. So we can write claim by it. So this hypothesis that is stated here is a null hypothesis. So now we can state the pair of hypothesis. We can complete the pair. So here's the translation, and the pair will be it. Will be composed by it and the alternative. The alternative will be HA, and the symbol for the alternative here, the appropriate symbol here, will be contradicting the null hypothesis. So it will be greater than. Okay, here it is, the alternative for no more than is more than. Yes, so while the null is saying no more than, the alternative is saying more than. Okay, and the alternative is not the claim, so we have to delete the word claim here. So this is the null and the alternative. So the next steps that we have to do now, we have our pair of hypotheses. We have translated to symbolic form, completed the pair. So what we're missing to do now is to sketch the distribution curve, and then locate and shade the critical region. Okay, a test can either be one tail or two tail. How do we know? We have to focus on the alternative symbol. As you see, for the z-test for mean, the critical region follows the direction of the sign of the alternative statement. Okay, the sign of the alternative statement can point to the left, to the right, or both directions. Bear in mind, we are in a less than or equal to and a greater than. So the greater than is pointing towards the right. So we have a right tail test going on here, and we need to take a snapshot or a snapshot of the right tail distribution curve. Here it is, our critical region as well as our critical point will be on the right side. We can easily paste this in a text box for maneuverability. Yeah. A right tail test. As you can clearly see, the alternative symbol is pointing to the right. Okay. And we can right click or shift F10, format. And for this shape, we don't need no fill and no line. So now we need to plot the critical value, because this is a critical value approach. We need two important numbers, the critical value and the test statistic. The critical value comes on the critical point, and then we have to calculate the test statistic to compare it with the critical value. Since our critical point is on the right side, so we can drop the negative sign. So our critical value is 2.33. Likewise, we have to put this as no fill and no line so that we can easily bring it closer to its critical point right there. So the critical value is 2.33. Okay, so now we need to, as the following step says, calculate the test statistic. Okay, and here is the formula for the test statistic, the z-test statistic, and we are going to do that now. We go to insert, we go to equations, and the z-test statistic is equal to, open bracket, x bar, which is 6.5, minus mu is 5, divided, okay, by sigma, which is the population standard deviation, 2.52, divided by the square root of n. N is 144. Okay, so here we have it. (2.52) divided by the square root of 144. 2.52 divided, so that's 2.52 right here. 2.52 divided by the square root of 144. Okay, so 6.5 divided by minus 5, sorry, that is 1.5 divided, and what we need to do now, we need to find what is 2.52 divided by the square root of 144. Okay, so the square root of 144 is 12. So it basically is 2.52 divided by 12. And that will give us a value of 0.21. So basically it's 1.5 divided by 0.21. 1.5 divided by 0.21. 1.5 divided by 0.21, and that will give us a value of 7.14. And this 7.14, we put it on the number line, plot it on the distribution curve, 7.14. okay, as the steps goes. Now 7 is greater than 2, so therefore now that 7 now is greater than 2, so it comes in the critical region. Okay, so therefore now, as these steps say, if the test statistic is in the critical region, we reject the null. Reject the null if the test statistic is in the critical region. Do not reject the null if the test statistic is not in the critical region. So because the test statistic in the critical region, our decision is to reject the null. Okay, now conclusion. It says if the null is rejected, then the alternative is the conclusion. If the null is not rejected, then the null statement itself is the conclusion. Always remember that you will start the test with 2 statements, the null and the alternative. After the test is done, only one will be the conclusion written in worded form. Okay, so therefore now, since we have rejected the null, the alternative is the conclusion. Okay, the null has been rejected, the alternative statement is the conclusion. And what the alternative statements say here? The alternative statement is saying that the mean is greater than 5. And this makes sense. The mean is 6.5, so it is significantly greater than 5. So we have to write it in worded form. We have to write the alternative, which is the conclusion, in worded form. And always begin by saying based on the data, right? Based on the information that we will provide with. All right, so based on the data, the mean time that students spend in the library is more than 5 hours. And here you have it, the Z-test for mean critical value approach, starting with the null, the alternative, the distribution curve, the test, the critical value on the distribution curve. Let us group this up so that this does not go out of sync. And the test statistic calculated, plotted on the distribution curve, it was more than the critical value. So basically, this is a critical value approach, comparing the critical value and the test statistic on a curve. And based on the data, the mean time that the students spend in the library is more than 5 hours. This is the alternative statement, that's the conclusion, because the decision was to reject the null hypothesis because the test statistic was in the critical region. Always write your conclusion in worded form, okay, beginning based on the data. Because for other data, the conclusion could have been different.